Hello, everyone. Thank you for joining us today. Today, we have a session about function orchestration in Azure. My name is Hassam Mohsini. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft, partners, and the open source community. It's also home to the Microsoft for Startups program. With a diverse mix of hands-on workshops, expert panels, and community events, there is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Daron Yöndem. Daron is a Microsoft Regional Director and a Microsoft MVP since 2008, with a focus on AI and Azure. He is a regular speaker at international conferences talking about AI, serverless, and engineering culture. Daron is the CEO of Deveload, a Solliance Partner Network Member. Feel free to ask questions during today's session, and also feel free to connect with us on Twitter. The hashtag is Reactor Abu Dhabi and MSFT Reactor is the Twitter handle. Also keep an eye on the Q&A tab where I'll be sharing links and resources relating to today's session. And with all that said, I would like to hand over the mic to our speaker to start the session.
Okay. Hello, everyone. Let me get set up here. Thanks for the introduction. So our topic for today is, as the title suggests, is function orchestration in Azure or in the world of serverless. And what does that really mean? Let's clarify that for a second. Oops, I did go one slide ahead. So in order to orchestrate something, in order to orchestrate functions, obviously this session and the presentation assumes that you did get into the functions world, which means into the serverless world. If you did build one or two functions, that's good. This session will help you understand, what's going to be ahead of the road, right? What's going to be coming up once you build more functions and start going into this world where you start building applications that consist of maybe tens of hundreds of functions. And when you do that, the problem that you have in your hand is, how do I organize these functions? How do I orchestrate these functions in the sense of, how do I make sure these functions talk to each other? And how do I plan that whole thing? How do I build the communication between these functions? How do I make sure the workflow between all these functions are running appropriately the way I want? And how do I manage these workflows? That's kind of the question for this whole session today. So that's what orchestration is about. And when we go into Azure, we got two different ways to do that. The first one is Azure Logic Apps, which is a beautiful solution. Azure Logic Apps is a perfect fit for people who want to orchestrate their functions without writing essentially a single line of code. So if you want to have some kind of an interface, it's either you or someone else, right? You might have built all these functions, and then maybe a business analyst or someone has to be able to define the workflow between these functions and maybe the logic, how these functions will be executed. So if you need some kind of a UI to be able to manage that, then Azure Logic Apps will be the perfect fit, which will essentially give you the ability to define a workflow definition file in a UI. We will go into there, but that's option one. The second option is a little bit more geeky because you gotta write some code. Essentially what you're doing with Azure Durable Functions is to define your workflows with the code that you write. It can be C# or JavaScript. Durable functions are available in a couple of different languages today, and it's still coming up for all the languages that functions itself supports. But durable functions, in short, is a library that you include into your project that is based on the concept is based on the TPL, task parallel library, and it helps you manage and define your workflows between your functions through functions themselves. You build some functions to orchestrate functions. So those are the two options that we have today to orchestrate functions that we have in Azure. And when I say in Azure, just keep in mind that the Azure Functions runtime isn't something that only runs in Azure. You can even run the Azure Functions runtime. I'm not going to say locally on your laptop because that's already something you can do, but you can install the Azure Functions runtime into your own data center, and you can even have the manager, the portal, and all that stuff, right? You can install all these things into your own, data center. You can have the functions runtime running on Kubernetes. So, long story short, you're not stuck. If that's the feeling you have, you're not stuck with, the cloud-based Azure, the hosted Azure functions runtime. You're not really stuck with it. You can take it out, you can download it and start. I mean, you can even go ahead and run the Azure functions runtime in AWS or GCP, right? No one is going to stop you, and that's something that you can do pretty easily. And everything that we talk about today, not necessarily everything, logic apps isn't something you can grab and install in AWS, but at least the durable functions part is not, vendor locked into Azure. You can definitely move it out to other platforms where you want to run your own functions. And what is durable functions? Okay, so durable functions gives you the ability to write stateful functions. What does that mean? That means your function can keep its state, pause and resume, or rerun if needed. That goes kind of back to the resume concept, but it is able to keep some kind of a state with itself, compared to the regular ways of running a function is like, you run it and you do something and then you're gone, right? It's like consumable functions. They don't necessarily live long. They just do something and get disposed, and then we can have another one. And managing states specifically between multiple functions, and we will talk about these. If you got multiple functions that are supposed to run sequentially, for example, then you end up, passing the state from one to another, which isn't really very easy to do. I mean, it is doable, obviously, but it requires a lot of manual work. And that's something that durable functions can help you out and make it really easy to accomplish. The durable function runtime will help you manage the state and create checkpoints along the way. We'll see how it happens. So you will be able to create checkpoints when a function runs and be able to restart but resume to that particular checkpoint from the start without necessarily running all the steps that you did run previously. So you have this function which is supposed to do 3 or 4 things, right? And after you do 3 things, maybe you're going to wait for someone, an external event or something, but you don't want to necessarily wait actively, which means blocking a processor or something, because in the world of functions, if you're blocking a processor, even if you don't actively use it, if you actively block a processor, you will be paying the CPU time. So what we want to do is to be able to kill in the function, save the state, kill the function, release the processor, and then be able to resume it, kick it up again, but this time resume it, which means not to execute the 3 initial steps that we did execute previously, but be able to skip those and be able to resume from the state that was snapshotted. And we will take a look into that. And this is where the durable functions helps us. And long story short, we got these orchestrator functions. We call those orchestrator functions. They're just functions that orchestrate other functions, and those functions help us to define a stateful workflow with C# or JavaScript or whatever, a language that the durable functions support. C# and JavaScript are the ones that I know, and I know there's work around. The team is doing work about Python as well, if I'm not mistaken. Definitely go out and do some Googling to get the latest about it. But if you're using a language that's not supported by durable functions, there's definitely going to be work in the future to bring that into pretty much. This is my hope and my guess. Pretty much to all languages that are supported by Azure Functions runtime. At least that's what I assume. Okay, so we set workflows. So what are you talking about? We're going to start defining workflows in code. It's not going to be JSON. It's not going to be a definitional language. That's what Azure Logic Apps do. We will be defining workflows in our C# code, so that means the workflow will be only editable by someone who knows, how to code, and that's the biggest differentiation between Logic Apps and durable function or orchestration between these two, systems. Let's say an orchestrator function can call other functions synchronously, wait for them, or it can call asynchronously and wait for them all together, maybe in a future point. We will do demos about this, but output from all these functions will be stored so that you don't rerun the same function again and again over. This is related to your workflow, right? You start the workflow, you're going to run a couple of functions, you run the first one, and the output for that function will be stored somewhere. The state of that function will be stored somewhere, and in this case, it's going to be Azure storage. There's a Redis provider that is in progress. I'm not sure if it's completed yet, but by default, the Azure Durable Functions runtime is using Azure storage to save all of these snapshots and the states. And the state will be saved so that the orchestrator function can resume and skip that task, but pre-populate the result into your code so that you can resume and run the next task in the pipeline, right? And like I said, the durable function runtime automatically takes snapshots of your progress. And when I said that, when I say automatically, there are clues to understand where the state is going to be saved and not. Long story short, maybe the clue that I can give you right now is it has to be a task. Because think about it, the TPL, the task parallel library, helps us manage threads, right? What if it helped us manage work that happens to run in a remote function? What if a task doesn't necessarily mean something that we run in our current compute and, infrastructure resources that we have, right? What if a task represents something that is going to run on another server, right? On another function? And what if we could manage the life cycle of that function that runs on another hardware just as a single task from within our C# code? And that is essentially what durable functions enables. It's beautiful. So the first scenario is the simplest one, function chaining. You got 4 functions, you just want to run them sequentially, that's it. And usually the easiest way to do this, or if we didn't have durable functions, the way that I would do this is you run the first function, you put a job into the queue, you put the output into the queue. If the output is too large, obviously, if you're saving a video file or something, you better save it into a blob, but then get the unique identifier and put it into the queue, right? So but you still have to put some kind of a state or result into the queue so that the second function can go look up the queue and see, oh yeah, there's some work that is done by the first function, so I gotta pick that up and continue running the second step. And this whole process goes along how many functions that you have to run sequentially. So, and again, this is doable. This is something that we did for years, to be honest, but there's a lot of work, right? There's a lot of plumbing going on, right? Put the job into the queue, take it out from the queue, make sure, messages are not, the queue isn't poisoned. So you get the point. It's not very easy because error handling is really complex. And you end up with all these, multiple queues that you gotta maintain as well. So what could we do? What could we do with durable functions? So let's see. I'm gonna start totally from scratch here, and open up Visual Studio from scratch. Like I said, start a Visual Studio instance from scratch. I'm gonna say create new project, and I will create a function app. Hopefully, it's gonna come up. Not sure why it is that slow right now. It feels like some, okay, there we go. Okay, Azure Functions, next. It doesn't matter where we create it, but let me actually leave it as it is. I'm gonna leave it as it is, function app 1, whatever. Let's create a project. So I will create an empty Azure function project. There's not going to be any functions in it. It's going to be totally empty, nothing in it. And there we are. So for me, in order to be able to zoom, give me a second. I gotta run something in the background here. Perfect. So when we look into this right now, you're gonna see that there are no functions in here. This is just a function app, and I'm gonna right click and say, hey, add new Azure function. And yes, add it. And here we are. This is a list of templates that we can use to create a new Azure function. You might already know HTTP triggers, timer triggers, so on and so forth, but the one that we're going to use is this one, Durable Functions Orchestration. So when we pick this one, it's going to come with a template that is going to be very useful for us to do our demo today. So I will pick that one, Durable Function Orchestration, and click OK. It's going to spin up a lot of code, a bunch of code that is gonna, be the example for us for the rest of the demo. So here, what we have here is three separate functions. We got three functions in a single file, which isn't necessarily something that I would suggest, because I usually tend to keep my functions in separate physical C# files. Whatever. In this case, we got three functions in the same physical file, and that's okay. Let's try to understand what's in here. The first one, let's start with the simplest one. This is a simple function, right? A regular function that is supposed to return a string saying hello, getting a parameter string, and returning say hello to whatever the parameter is. And then it returns hello world or whatever, right? So this is really a very simple function. The only difference is, if you ever build an Azure function, the only difference that you will notice is this one is a different trigger. This one is an activity trigger. So this activity trigger comes from Durable Functions runtime, Durable Function runtime. And an activity trigger means, hey, this is gonna be a function that is gonna do some work. And this function will be orchestrated. So from the context of Durable Functions, this is a work function. This is an activity function, and this is going to be triggered by the orchestrator. We will look into how, but the important thing to understand here is this is the function that is going to do the actual work, right? If there's going to be files to be copied, this is the function that's going to copy the files to be uploaded, downloaded, third-party REST APIs to be called. This function is going to do that. Activity trigger functions are the ones that are going to do the work and return some output. Okay, what else do we have in here? The other one, let's look at the first one. This is the first one, right? And this is, as the name suggests, again, this is the orchestrator. So this function is going to orchestrate how activity trigger functions are going to run, in what flow, in what order, in what condition, right? The workflow is going to be defined in the orchestrator. So in this case, what we have here is, it looks like the orchestrator is taking a list of strings, which is interesting. And then there's a parameter in the orchestrator that is an durable orchestration context with orchestration trigger. Okay, so these are coming from Durable Functions as well. And this one means, hey, there's going to be an orchestrator running here, an instance of this orchestrator will run, and I want access to the context where this orchestrator function is running, and that's why I have this as a parameter here, right? So the Durable Function runtime will give me the context so that if I want to talk as an orchestrator, if I want to talk to the runtime, this is what I'm going to use, right? Okay, so much with the definition here, and keep in mind, besides the Durable Functions runtime, all these functions, they have a function name, right? These are all functions. Some of them are activity triggers, which makes sense for the Durable Functions runtime. Some of them are orchestration triggers, again, which makes sense only for the durable functions runtime. And then when we look into the internals of the orchestrator, what we see here is, okay, this is interesting. So we are essentially calling function one hello, right? Okay, that should be this one, right? So it looks like we're not calling the function by its, C# function name. We are calling the function by its Azure function name. Cool. And then we are passing a parameter that says Tokyo, Seattle, and London. And this parameter, I am guessing, is going to be this parameter, the string name that we pass to say hello. Cool. Okay. How do we run those? Okay. It looks like we're calling something called activity, call activity async. String. Does that mean we are going to get string out of this? Yes, it does, because this activity is going to return a string. So I'm saying, hey, I'm going to call an activity. Who I am talking to? I'm talking to the context, the durable functions runtime. Cool. So we got the orchestrator running. The orchestrator gets a context, and I'm telling the context, hey, I'm going to run an activity. It is supposed to return me a string, and here is the name of the activity, and here is the parameter I want you to pass in. And then, because this is an asynchronous task, I'm gonna await, right? I don't have to await, but in this case, we do await. So we are waiting for the result to come in, and the result is string. Then we got a list of string, and it looks like we're doing the same thing over and over 3 times. We are calling the same function, passing Tokyo, returning the string, adding into the list of string. Calling the same function again with Seattle and returning the value, adding into the collection, and so on and so forth. And finally, we're returning the list of strings, which is going to return, something like hello Tokyo, hello Seattle, hello London. Cool. So the thing that you gotta understand, it's important to understand here, is this orchestrator. I know these 2 functions look like they're in the same physical file. That doesn't mean they're running in the same server. They can, or they might not. No one knows. The mindset with it is important to understand here. That the thing is, these functions can be running on separate servers, and that's why when we tell the context to run a function, we are not given the name of the C# function. We are given the Azure function name. When we do this, what's going to happen is that the orchestrator might be running on server 1. The orchestrator will call this function on server X. We don't know. And if we call the same function 1,000 times, if we need to scale, this might be a reason to spin up another instance of this Azure function app. So when we do this, we are actually, in the old-fashioned ways, we're actually putting a job into a queue, and then another function is getting, the job out of the queue and executing it and returning the result, essentially putting the result into another queue so that the main function can get the result from the queue, revive itself, and resume. And we are doing this sequentially for 3 functions. We're actually calling the same function 3 different instances, though. So this one, the first line might be coming from server 2. This one might be coming from server 3. This one might be coming from the same server where the orchestration is running. The point is, these are totally physically separated sandboxes. And if you look at it, this is kind of a beautiful and easy way to run this whole thing. The question is, who runs the orchestrator? Who is going to run that? Let's scroll down. Here we got another function. So in this case, it looks like we got an HTTP function because it has an HTTP trigger. It gets get and post, and it has a Drupal client. This looks different from this one. Okay, it has a Drupal client. It will get a starter. It looks like we got a Drupal function client here, right? Orchestrator client, orchestration client. And then what this HTTP function does is spin up a new version, a new instance, sorry, not a version, a new instance of function 1. Okay, what is function 1? Oh, it's our orchestrator. So this HTTP API, when it's executed, it actually gets a new instance of our orchestrator. And this one is because there's no data passed into the orchestrator in this case. It's gonna return a list of string, but it's not having any additional parameters besides the orchestration context. So that's why it's null. You can actually pass data to an orchestrator instance if you want to. And so far, I guess you already understood that we can have multiple instances of the same orchestrator. So we defined the orchestrator, which is going to do the orchestration for the workflow, and then we can have thousands of instances of the same orchestrator with different parameters, right, running the same flow for different things. Cool. So this HTTP function is running, the orchestrator. It gets an instance ID for the instance that we just created. And for the sake of the demo here, what they're doing is they're, creating the check status response and returning it for this particular instance ID into the request, which means when I call this HTTP function, I will get back a list of endpoints that will help me to talk to this orchestrator orchestrator client if I wanted to do. Because keep in mind, this says start new async. So the thing that we're awaiting right now is the initialization of the orchestrator, not the completion of the orchestrator. At this point, I'm running an orchestrator, and in a fire and forget approach, I'm leaving it as it is. I'm just returning some status for the orchestration client. Orchestrator. I'm returning some status for the orchestrator, but I'm not necessarily waiting for the orchestrator to complete. Because we don't know when it's going to complete. So you might ask, like, hey, where is this output going from the orchestrator? It's going to be stored by the durable functions runtime in storage. You can always come back with an instance ID. I'm going to show you how. You can always come back with an instance ID and get the result, but that's not what we usually do if you have to store something really instead of returning it from the orchestrator. I mean, this is usually a status or something like that. Usually when orchestrator, if there has to be something saved somewhere, the orchestrator shouldn't do it. An activity should do it. And the orchestrator simply should just report a status back. That's it. Because the thing is, when this code runs, and let's run it. This is too much talk, right? Let's run it. I'm going to tell you why we have to do our work in an activity. Because you might think like, hey, I can do it in the orchestrator as well, and I can save that file in the orchestrator. No, you shouldn't. And I will tell you why. Okay, here we go. We've got an HTTP endpoint. This is for the kicker, right? For the executor, for the initial one that is going to create an instance of the orchestrator. And I got a debug point where the orchestrator is going to be created for the first time. Let's go here, open up Postman, and we're going to need to submit an HTTP GET or POST. Oops, wrong window. There we go. Let's minimize this a little. Oops. Yeah. Okay, here we go. I'm going to minimize this a little bit. Give me a second here. Okay, perfect. We'll go here. Perfect. I will send a GET request. Here we go, our debug point. So we'll hit F10. Let me put a debug point here as well, right? This is the activity. F10. Okay, F10, and here we go. Activity started, right? The first activity, the first instance of the activity. This one has Tokyo as its parameter. Perfect. This is gonna return hello Tokyo. Again, F10. Oh, here we go. Okay, this is interesting. So I did run this task, right? once it was completed, I hit F10, and it looked like I'm starting from scratch to my orchestrator. Yes, because it's gonna need to resume. There is no way to jump, lines of code and go into line, in this case 22, and resume from there. Resuming means, in this context, resuming means not executing the same task again when you start from scratch. Well, let me show you. So we started, this is the second time that the orchestrator is running, right? The same instance though, keep that in mind. This is the same instance of the orchestrator. So this started from scratch, at least this looks like it started from scratch, F10. So I'm gonna F10 again. Let's look into the collection. The collection has 0 items in it, okay? So I'm gonna F10 again now, but this function with Tokyo parameter, we did already run that. So if this runs again, then this is gonna make sense. This is gonna make sense, right? So I will F10. Okay, what happened? So this is what resuming means. Because that task was already ran in the past, in the context of this orchestrator instance, it didn't run again. And when I look into my outputs, oh, there is one item in the collection that says hello Tokyo. Good. So we did actually resume right now. And when I hit F10 again, this time the same function should run with parameter Seattle because I didn't run it previously. So let me hit F10, and there we go. The activity function started. I will F10, 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 and I'm back on the orchestrator, and it looks like the orchestrator again running from scratch. Okay, so this time I expect Tokyo and Seattle not to trigger the activity, but London should. Let me F10 twice, and let's look into the collection, generic collection, the list of string here. Count 0. Okay, F10. Activity didn't run. I'm looking into the collection count 1. This is what snapshotting and stateful functions are about. That function didn't run. The execution state of function was stored and resumed. So I will F10 again, and we will see that the function will not run, activity trigger will not run for Seattle, and if I look into my collection, I got count 2. Cool. So I will F10. This time the activity trigger will run. F10, F10, F10. Final round. The orchestrator is running from scratch again. F10. Well, let me pin this down. Null. Cool. F10. Tokyo. Didn't cause, didn't trigger activity trigger. Count 1. Seattle. Count 2. London. Count 3. So this time, the whole thing resumed till the end of the function, and now it's going to return the output. I will F10, F10, and we're done. Perfect. So the orchestrator did run in total of 4 times, I guess. But it did resume, and it didn't run the tasks that it ran in its previous life. So now think about it. If I was, for example, right here, save huge file. If I was saving a huge file here, for example, I will save it 4 times. Because this is not in a task. This is not in an activity trigger, and the durable functions runtime will not track its state, will not snapshot its state. Long story short, work that you do has to be in activity triggers so that they don't repeat in every life cycle, in every life of the same instance of the orchestrator. If you do it in the orchestrator, there's no way for the runtime to keep its state, store it, restore it, and so on and so forth. So whatever you're going to do, you have to do in the activity triggers. The only thing that you have to do in the orchestrator is orchestration. That's it, nothing else. Perfect. Okay. And by the way, one of the things that we saw here is when I run this, HTTP start, this is the output. This is what we, check status response. We returned it, status response report. And if we look into there, it looks like, oh, there are 4 different endpoints that I can hit if I wanted to talk to the orchestrator instance. One of them says, hey, status query get URI. Okay, if I send a get request to this one, to this URL, it looks like I'm going to be able to ask the status of the orchestrator. Is it running? Is it completed? Cool. This URL has already the instance ID of the orchestrator and an access code. I can send an event. We will look into that. I can terminate the orchestrator, whatever state it is in. I don't want it to be resumed anymore. And I can purge history and clean up everything about that particular instance of the orchestrator because I want to clean up my Azure storage or anything like that. Cool. Awesome. Okay. I hope this is fun. So I just copy pasted the code into the deck here so that you can grab it. But in this case, this code is pretty much built into Visual Studio. I did show you the way how to get that out so you can do it yourself as well. The second problem is the fan out, fan in problem. So how do we really do that, right? What if I start with a single task, but out of that single task, there's going to be a list of a collection of things that I got to do. And for example, who should I say hello to is my first action. I go and fetch something from somewhere, a list of cities, and then I want to say hello to all these cities, not in a sequential way, but in a parallel way. And the hardest part is once I say hello to everyone that I want to go do something else. Think about doing this with queues. Think about how would you do that. Should I give you like 20 minutes? No, I'm not going to do that. But this is an easy problem to fix, right? This is very, very easy with verbal functions, because here's what we're going to do. I will go here. In this case, replace this part. Okay. What did I change? What did I change? So instead of awaiting every task one by one, I am actually waiting them all at once. That's it. This is it. They're all gonna, run asynchronously. What I'm doing is fan out. There's gonna be 3 different instances of this activity trigger running with 3 different parameters, and when they're all done, my orchestrator will resume. This is as easy as it gets. If you want to scale something, you got a collection of things. You got a collection of product IDs that you're going to send it to a third-party, API or something, and you want to spin out. You can have, Azure functions can scale indefinitely, so you can. The only thing I guess at this point you're gonna need to worry about is a throttling that you might end up having from the third party. But that's it. And this orchestrator, let me show you. Let's run this, because this is just beautiful. Okay, let's run this. Come on. Okay, same endpoint. I got the debug point, and I will send another request. Okay, here we are. F10. Single F10. Done. That's it. I sent 3 requests with 3 different parameters. F10. Resume. Cool. This is the second time this orchestrator is running. F10, F10, F10. That's it. The second time the orchestrator ran is when all 3 tasks were completed. And when I look into the output, I got 3 cities, right? All the tasks ran to completion. That's it. Isn't this just beautiful? I don't know. I just love doing these demos. It's so exciting to see being able to do this in a couple of lines of code. I mean, this is too simple. I don't know. Maybe that's just me getting excited here. Okay, oops. So the other one, let's maximize for a moment. The other one is the eternal process. I'm not going to do a demo about this, but as you can think right now, you can have an orchestrator running forever. It can wait for something. You can have you can have a timer out of the orchestration client as well. Here's a tricky thing that is not part of the slide deck. You can get a timer from the orchestration context. The reason you're going to get a timer from orchestration context, or if you have anything to do with date and time, you should get the date and time from the orchestration context, because otherwise the date and time will change in every resume of the orchestration instance, right? When it's resumed and you get date and time from the regular .NET API, you're going to have a different date and time. Is that really what you want? Because I don't think so. If you resume, you most probably would like to have the same date and time stamp that you initially created, for example, in your code when you ran the orchestration client, orchestrator for the first time, right? So in order to do that, you can actually, there's an API where you can get a date and time from the context, from the orchestration context. So that the next time you ask for it again, it will figure out that you are, the second resume or the third resume of the same orchestration client, and then it will give you the same time it gave you in your previous life cycle. It will figure that out. So be careful when you create a timer or when you get a date time. Make sure you get it from the orchestration context so that you don't end up, struggling with interesting problems. In this case, this is an eternal process that does work, and you can always use that API that I showed you to ask for the status. Maybe this is, a function that is going and checking the state of something else, a third-party API, and checking it and then sleeping, checking it and then sleeping. And in order to sleep, you can actually create a task that is going to sleep for 5 seconds. And when you create that task and you wait for it, your function will be terminated and will be resumed when the task comes to conclusion. Right? That's as simple as that. The other one is human interaction. So what if there were some third-party event that I would love to have interacted with my orchestrator? How do I do that? So let me show you that, because that's an interesting part. I'm going to copy paste some more code from here and replace this with this. Right. Okay, let's import some using statements. So here's what's happening. We're going to say all of our hellos. Wait for those, it doesn't matter. And then we have a cancellation token source. What we are doing here is I'm going to increase the 120 seconds so it's easier to demo. So here's the thing. I'm either going to wait 120 seconds or wait for an external event. This event is supposed to give me an integer in this case. And the name of the event is text message challenge response, right? So someone is going to call this externally. And what this returns is a task. And I got a timeout task here as well. I'm creating a timer, expiration, token, right? 120 seconds, okay? That means I got 2 tasks and I'm gonna wait for any of these 2 tasks to complete. That's it. And finally, if the timeout task isn't the one that is completed, I'm gonna make sure timeout task is canceled, right? So let's see how this works. I'm gonna put a debug point here, not necessarily here, here maybe. So let's run this because I really want to show you how to interact with this orchestrator. Okay, let's see. Okay, the endpoint is the same. I will first run this, and when I run this, I will get the report, right? And in this report, what we had is send event post URI. All right, this looks interesting. This looks like, you know, everything is in there except the event name. Okay, let's click on it. Where is the event name? Desktop, desktop, those are the parameters. Did the event name disappear? I think so, right? Task hub, when I clicked on it, yeah. So let me do this just to make it easier. I'm going to copy this, paste it in Notepad. Okay. And here I'm going to pass the event name. That might be easier. Okay, this is the endpoint we got to hit, right? So I will go here. So start from scratch. Post to this URL. Great. And then on the body, I'm going to say row and send to, right? And send a request. Oh, yeah, headers. Let me see. I don't want to miss anything there. Content type, right? Content type. Oops. Okay. Application JSON. Send. Wow. I did hit my debug point. What did happen? So let's see. Well, who is the winner? Oh, it looks like we got the winner. Result is 2, right? And where do I see? And completion, this one? No, so this one. Yes. This one is the one that ran to completion and the result is 2. So it looks like I didn't hit the timeout, but I was able to hit this orchestrator from an external event, pass a parameter, and have the orchestrator resume. It's actually what happened. So when we hit task when any, the orchestrator itself was terminated, not necessarily terminated, but you know what I mean, right? Killed. So I'm not paying anything to Azure. I'm not paying compute time. I'm not paying anything until either the expiry time comes in and my orchestrator resumes, or someone calls this event and raises my orchestrator back, and that's where I'm going to start paying for it. So if you have these third-party events that you got to wait for, you can actually pay for. You can actually wait for them without paying anything forever, unless you don't delete a storage account where everything is stored. But isn't this really very easy? I mean, try to do this without the durable functions. I mean, again, I'm not saying it's not doable. Obviously, these are stuff that, you know, people did for ages, but were they as easy as these, you know, couple of lines? No, definitely not, right? Okay, perfect. Let's go here. Oh, okay. We got some cheating notes there. Okay, this is the code that we used, and then logic gaps. So that's as much as we're going to do with durable functions. So logic gaps is really easy. So again, they help you define everything that we did so far in a UI, and they have a huge list of connectors. That's something I really love about logic apps. And these connectors, by the way, there's a preview right now. These connectors are being moved, not necessarily moved, but let me rephrase that sentence. So Azure function triggers will be able to consume logic app connectors, which is going to be beautiful because there's a huge amount of connectors that makes things really very, very easy to connect to a third-party service without really messing up with the REST APIs and stuff like that. So, but long story short, the primary value of logic apps is, yeah, the connectors are a huge value. And I guess if you ask the product group, they will say the primary value will be connectors. But to me, in this context, the primary value is the ability to edit things on a UI, right? So let's see really. Give me a second. I gotta Okay. Here we go. Let's go to the portal. Oops. I got this interesting display driver bug that sometimes comes in, and that doesn't really, that messes with maximized windows. It makes the top part of the screen not clickable, if that makes any sense. Okay, here we go. So I got a logic app in here that I prepped before this presentation. Let me move this over because I gotta hit a couple of, so I got this, I'm gonna copy paste a couple of endpoints. I got this function app, where's food detector. I already deployed this. I can show you what that is, by the way. Let me see, what is the food detector? It's not really rocket science, it's pretty easy. Let me see, okay. Food detector is actually getting a single URL of an image, passing it to Azure Cognitive Services to see if there's any food in it or not, and then returning a response. As you see, I'm getting a single URL. I'm calling computer vision. I mean, this doesn't make sense, I know. I mean, this is just a, sample. So I'm wrapping up computer vision client in an interesting way. If there is food in it, I'm returning the URL. If there's no food in it, I'm returning no food, which is the perfect design for an API. But, like I've said, this is just an example how things might work with logic apps. So I got that function deployed in here. Let me show you how that works. So I got two URLs in here, one with the image of a food. Running it right now. Come on. And I got another URL with an image that doesn't have a food in it. Okay, so the first one that returned the URL of the food, right? Let's see if there's really food in this. Yes, there's definitely food in there. And the second one says no food. There's no food in there. And let's see if there was really no food in there. Yeah, there's definitely no food in there. Cool. So the function is running, but I did come up with this crazy, and I'm not gonna call it useless because someone might need it. So in this case, what if? I mean, we got this function that tells us if there's food in an image or not. But what if I wanted to give a list of images and only ask the function return me the ones that have food in it? Right now, my function gets only a single image and returns if there's food in it or not. But instead, I want to be able to pass a list of images and then, get a list of images that have only food in them. So in order to do that, I did actually build this little logic app. I guess the one that was running is this one. Okay. So I will hit edit, and this is going to show you the beautiful flow I have in here. So what this does is it gets an HTTP request, it exposes an API, right? Then the next step is I'm parsing the JSON, and this gets a JSON array of strings, right? And then I'm initializing a variable, an array variable. And as you see, initializing an array is something you can drag and drop in the UI. That's how logic apps work. Then I get a for each. Cool. I do for each iterate through the body of this function because this function is supposed to get an array of strings, right? I'm iterating through them. I'm calling the food detect Azure function, which does the work, right? I'm passing the current item. I'm getting the result, and I have a condition here. If the result is true, if the body, right, condition says if the body does not contain no food in it, then do nothing. If the body, body does not contain food in it, append the current item. I'm iterating right through a list of strings, URLs. I'm passing each one to the Azure functions, If the result says no food, I'm not going to do anything. If the result doesn't say no food, then I will append it into my array that I just initialized here. And then finally, I will return a response, putting the full array of foods that I found. So again, this whole thing might make you think like, oh yeah, is this what it is? Of course not. This is just a small demo that I came for the sake of this, presentation. But the idea here is you got one, or you might have multiple functions that are doing atomic small pieces of work, right? Like activity triggers, and then you have to implement, for each loops, arrays, essentially decide in what order and how these functions are going to run and how they're going to interact with each other. And this is somewhere you can do it in a UI and hand it over to someone who can manipulate the workflow here in a UI. Let me show you how this works. This is going to be very, very easy. Let's go to Postman. This is the endpoint that I got from my Logic app. I will pass it in here. I will say post, and I gotta pass in an array of 2 strings. I got 2 images here. Send it. Oh yeah, I gotta get a new endpoint from here. Let me get that. It looks like my token did expire. And it send. Please work. There we go. I did send 2 images. I got only 1 back. It looks like the Azure function ran twice to detect if there's food in these 2 images, and there was only food in one of them. So that's what I got back. So this is how you can enhance or orchestrate the functions that are deployed. So the scenario might be, developers building functions that are doing activities, and then a business analyst or someone comes in and builds this flow, or you built the flow, but you build it with Logic apps because you want to be able to hand it over to someone, and they don't have the capability of writing code and deploying and so on and so forth, but they want to do it in a UI. Or the other thing that might be really useful is leverage the connectors that Logic apps have, like being able to connect to an Office 365 inbox, being able to connect to Twitter or anything like that, and you really don't want to build all that stuff yourself. So you build the Azure function that does the work, and then you wrap it with a Logic app that has all these connectors that you can put in front and to the end of the workflow or whatever you need, and you have a fully working thing in a pretty short amount of time. So that's pretty much it. So I just put a screenshot here just to give you an idea how it looked like. And here are a couple of links I wanted to share. Workflow definition language for Azure Logic apps. That is kind of not a very easy link to find, so I wanted to put it out there because like any UI, Logic apps to UI, sometimes you gotta go back to the definition language to be able to fine tune some things. So that link might really help you out to figure out things. The Dribble Task Framework is definitely worth a visit to understand, where this is coming from. And finally, the Durable Functions NuGet package is the one that you're going to need to look into and add it into your Azure Function app. But again, you did see me, creating a Durable Function app without really adding any NuGet package or anything, because I did add the template with the orchestrator in it, which kind of, in the back end added all the packages that I needed. So with that, that's it. Thanks for being here with us. You can download the slides from this URL, and I'm not sure if we had any questions or anything like that, but let me see. No, I don't think we have any. Oh, we do? Oh, it looks like, yeah, we do have some questions. Let me see. How how much data and state can we store in durable functions? Any limits? I'm sure there are limits. I don't remember any of those right now, top of my head. But I would say, don't. I mean, as a best practice, I would say don't store anything. And by that I mean just the things that relate to the state, right? Don't store as less as possible. That's what I would say. Because one thing that I didn't touch to is, if you put a lot of load on the storage, essentially Azure storage can be your limiting point of scale. And that's why there is this concept of maybe using multiple task hubs in the same function app, so that you can, partition the load across multiple storage accounts if you want to. But if I were in your shoes, I would try to keep everything as minimal as possible from a state storage perspective. And if you have really something else, something large that needs to be stored, I would just put the identifier into the state and put the data somewhere else. It can be SQL, it can be blob storage, wherever you can think of, but not really use this as a means to store things, but as a means to pass on something. I mean, maybe I can answer this question saying, how much data would you put in cookies if you were building a website, right? That should kind of give you an idea of what maybe I'm talking about. Let me read the other questions. Orchestrator, if we have these 3 lines of code, is count as 3 invocations for pricing? Oh, yes. So here's the interesting thing. If you look at yes, it does count as 3 executions, but keep in mind that the executions are going to be crazy small, the time that it takes to execute. Usually what I see is, I see a lot of 0 seconds, 0 milliseconds for a lot of the resume executions, because you are doing nothing, right? You're just passing state from one function to another. So the execution times are very, very small. Yes, they do add up, but they're very small. Unless you do something in the orchestrator itself. So ideally, no data storage, no data loading, no calculations, nothing. Your orchestrator should only have the workflow itself, like if statements, for statements, and that's pretty much it. It should be it. If that's all you have in your orchestrator, don't worry about resume, execution times. Don't really worry about that. Okay. I guess that's all we have.
Yeah, perfect. Thank you for today's sessions, Daron. Was wonderful having you in Reactor Abu Dhabi. I think we enjoyed today's session, and I'm gonna share a few links with the community now, and Daron recommended these. So the first one is create a long-running serverless workflow with durable functions. The short link is there as an announcement in the Q&A tab, so keep it open. I'm sharing some resources. And also there is this module on developing, testing, and deploying on Azure and Azure Functions with Visual Studio. So continue the journey and take these 2 modules. And don't forget to give us some feedback relating to the different topics that we're doing. So basically, the Reactor survey will ask you for an event code. Use this code 11746 for today's session, and give us some feedback about the session that you would love to see in the Reactor topics on cloud development, DevOps, AI, machine learning, data science, and so on. So leave us a feedback there. Take a couple of minutes to do so. Also, don't forget to connect with us on Twitter and subscribe to our YouTube channel, where you will find today's session very soon. Also, we send out a monthly curated email with all the interesting happening across the reactor, and that will be interesting for you to join the newsletter. We only send that once a month, as sometimes you might miss some things on Meetup, and this will make sure that you get notified about all the interesting stuff we're doing. Also, make sure you check out the calendar. There are so many interesting events that we're doing and sessions of workshops in the coming weeks. And actually in October, there are also sessions on cloud development, AI, and so on. So make sure you register for the events that you don't want to miss. And with all that, I'd like to thank you for joining us again, and goodbye. Stay safe, everyone.